Okay. I think we are all set.
Okay. Yeah, mine says live in the corner, so I think we're live.
Okay, perfect. Alright. So, you just want to, Andrew's just starting a movie really quick, so he'll be here in just a minute. But do you want to start going over the preparation assignment?
Okay.
So, alright, do you want to start with number 1?
Yeah, okay, so check the 5 assumptions for conducting a linear regression on the data. List the 5 assumptions below and explain how you check the assumption. Include charts, graphs where appropriate. So for A, I said that the relationship is linear between x and y, and then I said that it makes a hot dog shape because it's like that long kind of grouped up where it's kind of close together.
Okay, perfect.
For B, we said that it was normally distributed because it formed a, I guess it was close to linear. It kind of was in a little pattern there.
That's what I got too.
Okay. And then C, it's, sorry. It's, okay, there was an error terms that consists with all the values of x, and then there was no megaphone shape.
Okay, that's what I got. Then for D, I said that the x's were fixed and there wasn't any errors, and so we assume that the x's have been measured accurately.
And then for E, it was similar. We just assume that the y's are independent.
Yeah.
That the observations are independent.
Okay, so then for 2, it says test if there's a linear relationship between the head and length and body and length. And so to state the null, we said B1 is equal to 0 and B1 is not equal to 0.
Is that an, wait, is it supposed to be B1 and B?
No.
Oh. And then our alpha is 0.05, they said.
Okay, and then C, I got the test statistic 22.675.
Perfect. And for the p-value, it was pretty much 0. Which then was less than, so therefore we would reject the null.
Whenever we reject the null, it's always sufficient evidence in the linear relationship between the head and the body of the crocodiles.
Right. Then for 3, I said with the 95% confidence interval, I got 6.712 for the lower part and then 8.089 for the higher part.
Perfect. Alrighty. So we'll get going on the homework portion. Alrighty. So for 3, we said that it would be C.
Okay, let me open it real quick.
Okay, yeah, just let us know when you're ready.
Okay. Okay, so 3. Okay, yeah, it would be 3 equal to and then not equal to. And then 4, I would say B. It's the difference between the observed value y and the value predicted by the regression line.
Yeah, that's what we said as well.
5, we said C. You see a megaphone shape in the residuals.
See, that's what I got.
Okay, and then for 6, it says compute the residuals of the math self-efficacy data using software. Use the confidence data as the explanatory variables and the score data as the response variable. What statement best describes the residuals? So do we pull up the math self FSE, right?
Yeah, so I only did before the meeting till 5, so I need to pull that up. Main page.
Amanda, do you know, so we pull up the math self FSE. I can't say that. Gosh. Okay, we pull up that data, and then what do we put it into?
I think we're using linear regression in the quantitative inference procedures Excel sheet.
Okay, I couldn't find it. So quantitative.
Because that's what we used for lesson 22. So it's the quantitative inference procedures.
Okay. And then yeah, linear regression. Okay. Perfect.
Okay.
And then what did it say? It told us, right? It says use the confidence data for the explanatory.
Okay.
So the confidence, because that's what messed us up last time, right? We couldn't.
Yeah.
Right.
So that means the score goes in response, and then confidence goes in explanatory. Okay. Okay. So if we look at the confidence interval,
Says, which statement best describes the residuals? The residuals are all negative. The residuals form a linear pattern. Go down the wall. Keep on.
I would say it's a linear pattern.
The pattern.
Like they're not all negative, and they're not in between negative.
From looking at that graph that they have,
yeah.
I mean, it's all kind of clumped together, but it doesn't look like any of the ones that in the video that they showed.
Yeah.
But they're kind of clumped together. I don't know.
I think that would still be linear because they're all in the same general area. Because it's not like they're super spread out.
Right. There's somewhat of a pattern.
Yeah.
So I would think that it would be C.
Yeah. Because it's not between negative 40 and 25.
Right, and they're not all negative.
Yeah. So.
And then based on it, the next question doesn't it look right skewed?
What?
Isn't that right skewed or is that left skewed?
I think it's if the residuals form a linear pattern, therefore.
So residuals are, that's what we said is the difference between the value of y and the predicted value of the regression line.
Yeah. Hope the picture
Residuals are fairly normal. So I think that this one would be C2. The residuals are fairly normal because in the book online it shows one that's scattered and said that since it's scattered, the residuals are not normal, but then if they're more grouped up together, then they are normal.
Okay, that's what Andrew said too. So, okay, we'll go with that one.
Okay.
Let's see. Use software to create a scatter plot of the math self-efficacy data. Given the scatter plot, residuals plot, and QQ plot, which of the 5 assumptions about linear regression are satisfied by this data? Check all that apply.
There's a linear relationship.
It's gonna be all. So this is just asking the requirements, isn't it?
Yeah.
Yeah.
Satisfied.
So wouldn't it be all of them?
Yeah, well, just let's read and just make sure. But there has to be a linear relationship, which one is that? Yeah, that's A. And then a normal error term, which would be a variance of the error term is constant, and then constant variance. Yeah, x's are known constants, and observations are independent. Normal error term. The norm is a B1. The residuals are normally distributed.
Is what?
Is B1. The residuals are normally distributed.
Wait, are you asking what the definition of B1 is?
No. Would on number 8 would be
the
residuals are normally distributed. Would that be one of the requirements? Because I'm looking at them right now, and I'm just trying to. See which one.
The question's asking which of the 5 assumptions about the linear regression are satisfied. So residuals are normally distributed. I think we would check that because when we look at the graph, they're pretty normally distributed. They're all in the same area.
That's what I thought too. Yeah, but it's asking the 5 assumptions.
Because then that'd be similar to question 7 when we said the residuals are fairly normal.
Right.
Because if it wasn't normally distributed, it'd be more scattered and spread out.
Yeah, I think it's all of them.
Me too.
Okay, so then for 9, it asks the SB1, the estimate of the slope. We have 12.725.
Yep, that's what I have. And then confidence interval for B1 would be 10.708 and 14.742, so A.
Okay, perfect. Okay, so, and then based on the evidence, confidence interval. Sorry, my computer's being slow. Let me.
It's okay.
Okay. What decision would you make regarding the hypothesis test for B1? So, well, isn't the p-value is 2.34, so it's greater than.
Wait, but then it says e to negative 24. So wouldn't that make the decimal go to the left a lot? Like 24 places?
Oh, I don't know. Maybe. Is that what that means? I don't know what that means.
E. Doesn't E stands for error? The error term is E.
So then it would be less than.
Yeah.
So then we would reject the null because the p-value is less than A.
Yes, so B. And then 12 for hypothesis test for B1. If you reject the null hypothesis, what does it mean? So rejecting the null means we have sufficient evidence that it is not 0, because that was, or wait, we rejected null, so we have sufficient evidence. Yeah, so we have sufficient evidence that the regression line is not 0, because that was the alternative.
Okay, yes.
So it would be C.
Yes.
For the
Whatever data.
data, which variable is the dependent variable? Say body length.
You think it's
Yeah.
I don't know.
Wasn't that was in lesson 22, I think.
The dependent variable depends on what the other variable is. So if the head length's longer than the body length.
Wait, so explanatory and response, which one's independent and which one's dependent? Explanatory is independent and then response is dependent?
I can't remember. That was from last lesson. Let me see if I can find it in the textbook.
Because in lesson 22, the explanatory variable was head length and then the response variable was body length. So if body length is dependent, then dependent is the response variable.
Okay, I'm reading in the book. Let me see if it says anything. Let's see.
Oh yeah, the response variable is dependent.
Okay.
Dependent.
So then it would be body length, right?
Yes.
Okay, perfect. Since the 99 confidence interval for these data is 7.124 and 8.311, what can you say about B1?
There is a 99% chance that the confidence interval will contain a true value of B1.
Would it be B? There's a 99% confidence?
Yeah, that's what I would say.
Or is it A, since the confidence interval does not contain 0?
No, I don't think it's so.
No, I think it's B.
Okay. Did you have any questions on any of them?
Nope.
When we create a confidence zone, we say that we are quite confident that the true regression slope is between the lower limit and upper limit.
14.
What would we be?
So,
Yeah. Cool.
Okay.
Wait. 3, 2, 3, 4, 5.
okay, so I submitted it and we got 75%.
What did we get wrong?
So we got 5 wrong,
Okay, so it's not the
6
negative.
wrong.
Does it say what 5 is?
No, it doesn't show me what the answers are, but it says 5 and 6 are wrong, 8 is wrong, so not all of them are right, and then 14. So we got 4 wrong.
So we got 5, 6, 8, and 4.
Yep, and 14.
So
So I
okay.
think Andrew might be right. 14 is probably A, because
I don't
it's
know.
not C.
That confuses me. I don't get that.
Yeah.
And then 8. Okay, I don't know.
Let's see, go up to 5. Let's see.
I don't know what 5 would be. I thought it talked about the.
The plot of residuals supports using linear regression. Oh, when you see a pattern in the residuals, is that it?
I don't know.
Yeah. When you see a pattern, it's either a pattern of the hot dog shape or a pattern of.
Does it say on 8, like, did we just get it wrong, or like you get some points if.
We just got it wrong. I got 0 out of 1 because we marked all of them. So you either get 1 point or you get no points.
Oh, that's lame.
I don't know what it would be for 6. I
I
thought
don't-
that's what it was. Residuals form a linear pattern. The residuals
Because they're not all negative.
25 residuals are all negative.
Maybe they are between.
You do one, non-do one, I don't know.
Well, we are going to get 8 wrong because I don't know what it is.
8. I don't know, so I'm going to do
Maybe the residuals are
9.
different than the confidence. Residuals? How do you know what numbers residuals are between?
That's what I was wondering. Can I submit it?
Oh, I didn't notice this before, but in Excel, they have a column labeled residuals.
Well, where is that column at? Oh,
So
there
there's
you are.
explanatory, response, explanatory, and then residuals.
Oh,
Yeah, I don't know how I didn't even see that,
I didn't
but
see that either.
I guess that's how we know. But we'd have to look at all of them to know what they're between.
Um,
Watch it make it worse.
and then I finished, or I did it. I'll read you what our take action is,
Okay.
and then if we want to add some as a group, we can. It's fairly short. I mean, I did 2 paragraphs, but they're just little paragraphs.
Yeah, that
Um,
makes sense.
But this is what I wrote. So I kept your line. This is a summary of what we learned and what we would do differently. By collecting the data in Rexburg, Idaho, and Moses Lake, Washington, we were able to conclude that there is more male buried than female buried in both cemeteries. We were in both cemeteries. We were also able to conclude that Rexburg, Idaho, had more males buried than Moses Lake, Washington. To collect our data, we went to 2 different cemeteries. Okay, to collect our data, we went to 2 different cemeteries in Rexburg, Idaho, and Moses Lake, Washington. At each cemetery, we observed 35 single headstones, totaling 70 headstones from each town. Something we would do differently is the number of headstones we observed. If we observed more headstones, then we would be able to have a larger sample size, which would result in a more accurate conclusion. I don't
Okay.
know. I don't know if you want to add. I don't know.
That's what I was thinking of saying too. Like, normally in taking action, I think when it's not, like when you want to be more accurate, you just do a larger sample size.
Okay.
So I think what you have is good, and then maybe we could add on a little bit to what we learned. So we could say, wait, for last week, make inference. So last week, we could say that, we could also say, we, that we found insufficient evidence to say that there's a difference between male and female tombstones in Moses Lake versus Washington, even though they were really close in numbers.
Okay, so we learned that there is insufficient evidence, right?
Mhm.
Evidence. Insufficient evidence that. Sorry, what did you say? You worded it good.
So there's insufficient evidence to say that there is a difference between male and female single tombstones in Moses Lake, Washington versus Rexburg, Idaho.
We learned that there is insufficient evidence to say that there is a difference that male. Okay, wait. We learned that there is insufficient evidence to say that there is a difference between male and female tombstones in Moses Lake, Washington versus Rexburg, Idaho.
And then after that, we could say, even though the data were extremely close in numbers, like the number of male versus female tombstones, we still had insufficient evidence. So, like, the numbers were only, like, when you look at the data, the numbers were only, like, 1 to 3 off. So
Okay.
they were really close to being equal to. So
even though the data were very close in numbers, we still had efficient evidence.
yeah.
Okay. Okay.
And then I think that should be good.
I think so too. I think, we talked about what we kind of like did, what we learned, and then what we would do differently. I think that's good. Because I think you have to fit that on a PowerPoint, so I don't think we want it too long or too wordy.
Yeah.
So, and then I think all you have to do is just combine everything, each assignment into a PowerPoint, right? You don't have to create, like, new everything.
Yeah, so I think some of it I just have to like shorten it or only take certain parts from assignments, but overall I just use the assignments we have and put them into a PowerPoint, like organize them together.
And then we're sorry about our graphs. I couldn't figure out how to change the color. So that's why some of them are like, I don't know. I couldn't figure it out.
Yeah, I think I'll figure out how to change the color because the teacher said something to me in his comments for one of our assignments
Yeah.
about the color not matching up, but I'm pretty sure I could figure that out pretty easily.
Okay. Yeah, he had written it in one of ours too, and that's what I'm like. Oh, I'm sorry. I tried to like figure it out, and I couldn't. So
Yeah.
I'm just gonna submit it.
Okay.
So yeah. Other than that,
So-
I'll just fine tune this really quick, and then I'll email it to you tonight, like in a few minutes.
Okay, cool. Yeah. So then whenever you're done with it and think it looks good, just email it to me and then I can put it in the PowerPoint.
Okay, perfect. And then I think we're good with meeting. I was looking though at our for next week. So for lesson 22 or for lesson 24, our group meeting is the review for the test.
Right.
So then I don't know if we have to meet as a group. I mean, it says that we have a group meeting, but I don't know if we really have to meet for lesson 25.
Yeah, so I think maybe lesson 25 is, I'm assuming because we can't view it till Thursday morning,
Right.
but I think that's just one final group meeting to talk about like group project stuff.
Okay.
So we could probably just meet. So we'll meet tomorrow for lesson 24, and then Thursday we could just meet, and it will probably only be like 15 minutes just finalizing project stuff and making sure everything's turned in.
Okay, perfect.
Okay.
Alrighty. Yeah, and then we'll let you know for tomorrow what time we can meet. I did look at the group meeting, and there's like 43 questions, so I think it's going to take a while.
Okay.
So
Yeah, whatever time you guys can meet, even if it's late, I can do it. I'll just be in the living room if my roommate needs to sleep or something.
okay, yeah. Andrew just has mutual, so we'll see what what he what their schedule is for that, and then we'll let you know.
Okay. Okay, yeah. Just whenever you find out, text me sometime tomorrow, and
Okay.
yeah.
Okay, perfect. Alrighty, we will let you know for tomorrow, and I'll email this to you as soon as possible.
Okay. Okay. Awesome.
Okay,
Sounds
thank you.
good. Okay. Thanks.